Z schema, okay, for today's lecture, let me explain to you about what steps that you are going to do in your assignment, because starting from this week, you have to start with what we call as data abstraction already. Okay, so last 2 weeks, you have just list down all the operations, the requirements, and also maybe some of you had drawn ER diagram and so on. Up to last week, these are the things that you should have, okay, inside your assignment with your introduction and so on. These parts can be similar if you are following software requirement engineering assignment, title and so on. You can make it similar with the SRE except ERD, because ERD normally not inside the SRE. Okay, but after that, okay, starting from this week onward, will be individual part already, will be individual. The difference will be actually totally different already from SRE, because what you are going to, starting from this week, will actually related to Z schema already. Okay, when you want to start your Z schema, the first step that you have to do will be basic type. Then after that, you are going to do free types and so on. So here I will show you the whole step first of your Z schema. Then I will give you some example up to one place there. Then after that, I will proceed with the lecture. Okay, so let me put the steps first. Okay, so starting from this week onwards, your assignment related to your Z schema will have 8 steps here. Okay, 8 steps. So this week, okay, what you have to do is step 1, 2, 3, where we call this as data abstraction. Okay, data abstraction, where you have to list down your basic types, you have to list down your free types, and you have to list down your axiomatic definition, if any. If any means that if you have, okay, if you have for your system. If you don't have, then you don't need to put axiomatic definition. Okay, so after you have done the data abstraction 1, 2, 3 here, then you are going to start with what we call as state space schema. Okay, state space schema, each of you will have at least one module. If you have 2 modules, then you are going to have 2 state space schema. Okay, so minimum. So your state space schema is your module. Module name, whatever that you are going to include inside that module. Okay, so that's what we call as state space schema. Later, I will put this inside Google Classroom. So it's okay for you not to take the picture if you don't want. Okay, so later I will put in the Google Classroom also. Okay, so after that, after your state space schema, you are going to do initial state, where initial state will be very simple to initialize your variable from your state space schema. Okay, so after you have done this, then you are going to start with the operation schema. Operation schema, remember, each of you minimum, you have to do 3 operations. Okay, so 3 operations. These 3 operations are what we call as operation schema later. Okay, so it can be query. Query means, let's say you want to produce report. Report does not change your database data. So that is what we call as query schema. Something like update record or add record and so on, those are changing data in your database. We call this as change schema. Okay, change schema means something that will be updated into your database. Something like query is just you ask to display information, to display the report and so on. Those are query schema. So whatever that you choose, okay, for your 3 operations, you are going to do later as the operation schema. Okay, so after you have done the operation schema, you will proceed with what we call as error scenarios or error handling. So when you do operation schema, all the segments there are a successful schema. Means that can proceed. If the customer does not exist, then you add the customer. If the customer exists, then you don't consider that you cannot add. For example, you just consider all can proceed to update the database and so on. So those are successful schema. So normally those are actually under operation schema. So error scenarios is to consider all the operations where you cannot add the customer into database. Or what is the precondition that you cannot fulfill? For example, customer already exists in your database. How to add customer if already exists? So that is problem there. Then you have to provide error message. Okay, so error handling. You are going to create each individual schema for that. So we call that as error scenarios. Okay, so after you have done that, just now you have the successful schema, then you have the error scenario schema, then you have to combine these for the same operation. Okay, means that add customer, here error for add customer, for example, you have to combine this as what we call as complete schema. So that is the final part of your assignment related to Z schema. So after this will be, normally this one we will try to finish by week 12. Okay, so this is week 3 already. So you have a few more weeks to go before your submission on week 13. Okay, so by week 12, normally we are going to try to go until complete schema already, so that by week 13 you can just, after that you just compile your reports and then submit on week 13. Okay, so that is actually what we are going to do in our assignment related to Z schema. Okay, so now how to write, because this is the list only. So assuming that, because I told you, in your assignment, don't choose library system. So in this case, assuming that in some of my class, I just explained a bit. So let's say I have modules in my library. Let's say I'm doing library system. So I have a few module. Okay. in my library system. Let's say the first module is user module. Then I have book module. I have registration. Booking. Booking or booking. Okay, reservation. With booking or reservation. Okay, and then maybe also because library normally if you want you can have payment, okay, for those overdue you can have other modules. Okay, let's say these are the modules that you started with your assignment, right? Okay, so in this case I will handle book module, for example. That is my module. Okay, so when you want to start with, the first step is basic type, right? Basic type, your first step to do basic types. Okay, so the step here, list all basic type from all module, means from all modules here. Let's say user, the basic type are actually no need for me to use microphone. Let's say for user you have user ID, for example. Then I want you to write some description. For example, the set of all users is the library, for example. Okay? Then maybe for user you have username. Then you do another description. Then maybe for user you have user email, for example. And so on. Okay? You have a lot of here for user. Then you do all these things. Then after that, book. Okay, because you combine all into basic type. So for book, let's say I have book ID.
Translation.
Okay. The set, blah blah blah. Just write the whole thing. Then I have author. Okay. Then I have other category. Because that is library. Name. Title. Title. And so on. For example, then the rest, you list down all the basic types. Okay, so you have to list down, let's say booking, reservation, what is the basic type of booking, so you list down all. So these are actually basic type. Okay, you know the rules of basic type already, right? So after that, the second step is free type. Okay, let's say user gender. You want to go for gender. For example, free type, female or male? Male. For example, okay, that is for user. Want to have free type. For me, let's say category just now. Don't know a category. Let's say category. In the library, one child. That's for whatever lah, you just put lah. Okay, and so on. Okay, so free type lah, free type. Okay, maybe reservation. Maybe I have payment, whatever. Then maybe I have payment status. Payment status, for example, paid, unpaid, and so on. Okay, maybe I have this in my system, status for payment, paid, unpaid. Okay, so you list down all the free type that you want. Okay, so these are also global, means that other people also, they can use this. Let's say in gender here can be used in your friends, where the staff, some to customers, some to staff, they want to check on gender, you can still use it because it's global. Yeah? So after that, the third step is axiomatic definition. Remember what is axiomatic definition from last week lecture? So normally we this to indicate whether limit or capacity of constant value. Normally we use that to limit constant of capacity whatever lah. So how to write down axiomatic definition? Okay, axiomatic definition. This one is, if any, means that not everyone will have this. Axiomatic definition. Not everyone will have this. So it's up to your system. Maybe one of you will have, another team does not have. It's okay. Does not mean that everyone will have axiomatic definition. It's okay. Okay. So what is the symbol? Okay. For example, let's say I want to have to show the capacity of the books in my library. Okay. I can show two ways. Okay. Maybe using this axiomatic symbol. Okay, let's say I put capacity of type N. Okay, so I can put indicate how many. For example, I put equals to 10,000. Okay, or I can write also less than symbol. You can write like this also. Same statement. Doesn't matter whether equal or less than or equal, no problem, whichever you prefer. Okay? If let's say you want to say you have capacity, but because you are talking about in the campus, maybe you have two different libraries. One library is our normal library there, near car park there. Another library is in Postgrad, East Campus. So you have two libraries, but different size of the library. So one library can go for 10,000, another library maybe 5,000. Okay, so you don't want to put the capacity. So another way is, or okay, you can just do the second line here, like this, the bar only. So you just put like this only. It's either one. Okay, either one only. So either you put the value, the constant value, or without the constant value. Okay, so this is axiomatic definition, something like you want to show the constant in your system. Means everybody, if they want to talk about the capacity, they know that the maximum is 10,000, for example, or you know that there is a capacity in the library, but it's up to what library you are talking at that moment. So maybe you are talking about the library of car park here, so maybe 10,000, but the library in the Postgrad, maybe you say 5,000, for example, so different capacity. So that's why you didn't want to put the exact value. So if you don't want to put the exact value, you just put bar and then you put inside. So these two symbols on your left side here are actually for axiomatic definition. So axiomatic definition also will be global. Okay, global means that everybody can use the same one. If let's say your friends also have axiomatic definition. Okay, for example, let's say, for example, your friends want to have login 3 times only maximum, for example. So, you cannot put down here, you cannot put inside the same axiomatic definition. You have to do individual axiomatic definition for one single variable. Means, if you have 3 axiomatic definition that you want to say, you have to use 3 axiomatic definition symbol. Let's say your friends want to say login limit, for example. Okay, let's say login limit of type N, for example. Okay, so you want to say that login limit less or equal to 3, for example. So there will be one symbol for capacity, one symbol for login limit. Okay, so means that you will have to do separately. You cannot combine, because all N or Z are same thing. You cannot combine, you have to do separately. Okay, you have to do separately. So this is axiomatic definition. Okay, this is axiomatic definition. So your task for this week, you have to think of your free type, also your basic type, and maybe either you are going to have axiomatic definition. That is your task for your practical result. Okay. Yeah. So up to here, I think you have learned what is basic type. You have learned what is free type. Okay. Last week also you have looked into the axiomatic definition. Also, so all these actually you should have the knowledge already about how to do the basic type, how to do the free types, and so on. Okay. Just that you have to consider. So what are actually how to find the basic type and free type? Imagine your database record. Okay, imagine your database record. For example, okay, let's say in my book database, I have a few. This is my book table, table book. Okay, for book. So I will have, let's say ID. Then I will have title. Then I will have author just now. And maybe I have year. Okay. And maybe I have some category. Okay, for example, these are actually the information that I will have in my table for my database. So ID maybe I have B001. Okay. For example, B004, whatever lah, and so on. These are the records I will have in my database. Title, just put lah whatever title, and so on. And then author also, this is the string data. Year maybe this is 2023. This one is 2022, and so on. The year published. Category maybe this one on shelf. Okay. This one may be on shelf also. And then maybe you have another category books and so on. Will be other. Okay. So imagine that what are actually the information that you are going to store inside your database. So this information is the one that you are going to use here. For example, this is string data. When it is string data, automatically this is basic type. This is string data, also title. Then this is also basic type. This is also author, string data. Okay, so same thing, basic type. Year 2023, not string, also not free type. Should be built-in type. So when it comes to built-in type, it's either Z or N. But here normally no negative year, so we will go for N later. Okay? And then on shelf here, so this is the one that you may have a few choices, for example. Just a few choices that you want to have. Then if you want to have choices like that, one specific choice for that book, then you can make it as free type. So that's how you choose what are the type that you are going to do later. Draw something like when you want to start do the data extraction, imagine what your database looks like later. Okay, what are the information that you are going to store inside your database later. So from there, if the information are string data, automatically this is basic type. If those information are choices, automatically you define those as free type. And then if those information are integer value, then you are going to go for Z or N. So we have only three types, right? Built-in, free types, and also basic type. So just these three. Other than that, we don't have. Okay, so from here, you can see that what will be the information that you are going to do later. Okay, so like that basic type, then you just put as an ID, I make it as book ID, for example. Same thing. For here, I didn't use the word ID, but I want to differentiate between user ID and other ID, so I separate become book ID, for example. I can use ID, no problem. But for me to be specific, then I put book ID. So you can have this kind of basic type names. That's why basic type, another name actually we say as given set. Because we actually the one who are going to create basic type in our system. We are the one who are going to do that. So when we do that, we follow our own style. Okay, so ID here, I don't want to use ID. I want to use book ID. It's up to me. Okay, because I am the one who's going to do that in the system. So that's why another name for basic type is given set. Okay, given set. Okay, so that is actually how you choose this one. Okay, after that, after your axiomatic definition, the fourth step is state space schema. Okay, before we do state space schema, let me give you a lecture first. What is actually state space schema? Because if I tell you about this, you will get confused first. Okay, so up to now, okay, for your assignment purpose, you should already know how to proceed already with your assignment later. Okay, so now let's go to our continuation of our lecture first. Okay, so the fourth step just now is about Z schema. Okay, so Z schema, as I told you, the first one that you are going to do are actually what we call as state space schema. So this one, okay, why we call that the term schema? Because we are going to use specific symbols. So for Z, this schema is a small piece of information in Z. So the word schema is to represent small piece of information inside our Z. Okay, so in the schema, you will have data, you will have either data schema or operation schema. Later, you will see all this inside the lecture, and also later I will show you again the word result. So the schema can be separated into two. One is static for data, another one is dynamic. So static, okay, is your state space schema. Why it is static? Because this schema will communicate with your database just now. Okay, whatever that you put in your state space schema, those variables, those information is actually the rules for your module. Whatever the information that you put in your static schema will be the one that you communicate with your database. Also, whatever the rules or constraint or condition that you put in your state space schema will be the constraint for all the information related to your module. Okay, so it's like global. Your module will be global for your operations, will be global for you. So whatever that you put there will be global for your module. Okay, so this schema is for you to communicate with your database, dealing with data. Okay, dealing with data. So we call this as static schema. Okay, static schema. So deal with data. So the way to write, whether static or dynamic, will be similar. The way to write, we are going to use the schema symbol and so will be similar. Just that, remember the static schema is the starting state schema. That is something that you are going to deal with your database data later. Whatever the variable that you put in your schema, whatever constraint, condition that you put in your static schema, all those are actually global to your part. Okay, global to your part. So everything must follow those constraints and so on. Okay, so you will see inside state space schema here later lah. So you will see how you are going to do state space schema later. Whereas the word dynamic means, I think all of you know what is dynamic. It means changes. There will be changes and so on. So dynamic schema normally will be your operation schema. Because in your operation schema is something that you are going to make sure that you can do some operation function to do some changes, to retrieve the information and so on. So something that you have to do, operation that you have to do to make sure that you can do something. Okay, those are dynamic schema. So similar way of writing, just that for dynamic schema, later you will learn there are a few symbols that you have to put to show whether this is changes or not to your database, without changes or not in your database. There are one or two symbols that you have to know how to do it. Okay, but the only difference is either the static means you are dealing with database, dynamic talk to your static to communicate with the database. So dynamic will have changes. Okay, means that the dynamic is like operation function that you say, oh, I want to make changes to my database. So something that will change your database data. So these are the dynamic schema. So normally dynamic schema will be your operation schema. Okay, so that is actually the aspect of your Z schema that you have to know. So these are the ones that I showed you just now. Actually, you will have state space schema, initialization, and so on. Actually, these are similar from the word just now. Okay, and then there are 3 things that you are going to see later in your Z schema. So in the tutorial last week, we have actually discussed a little bit about, one part is about how to give the schema name. Okay, so when we talk about schema, okay, I've shown you the schema symbol also last week, but here also later I will show you the schema. So the name of the schema, okay, so always starts with capital letter. If you have 2 words, okay, every word must be combined into one word. Okay, without digit, without underscore, without symbols and so on, without space bar, combined into one. And then each word must start with capital letter. Okay, so that is schema name. And then you will see that from the schema symbol, there is a declaration and also predicate part. So this is actually the schema name that you have seen previously. Okay, the one that I showed you, okay, the schema name, but later I will show you again where to get the schema. So normally the one that we are going to use in our Z will be this symbol, graphical font. Okay, graphical form. We are not going to use text form for the time being, except during our last steps, complete schema. We are going to use the text form later. Okay, but for starting after the axiomatic definition, when you start with your state space schema, everything will be in graphical form already. Okay, graphical form. So the last part, the complete schema, you are going to use both schema, text form or graphical form. Okay, from now, just remember the graphical form. So you will see that here, just now you have the schema name, as I told you, capital letter, and then you cannot have digit and so on. So these are actually how you write the schema name combined into one word. Every word must start with a capital letter. No digit, no underscore, no symbols and so on for the schema name. Okay, always start with a capital letter. Okay, so for the declaration part, okay, so for the declaration part, this is where you are going to declare your variables. Declaration means for your variable declaration. Okay, and also later, okay, maybe, okay, for example, when you do operation schema, okay, you want to call your friends module into your system. So this is also can be added in the declaration part. Okay, but normally if it's actually related to your module only, declaration part will be variable declaration. Okay, your variable declaration, whatever that you learn variable before this. So this is where you put your variable declaration. Okay, so every line in your variable there, declaration, one single line, actually should have semicolon. But for us in Z schema, when you use the notation of graphical form just now, we don't have to put semicolon. No need for you to put semicolon. It is assumed that every single line will end with a semicolon. Okay? But if, let's say, you bring the second line, go to the first line, means move forward, then you must put semicolon. Similar like programming lah. But programming you have to put semicolon lah. But here, if you move the second line, put at the first line, you have to put semicolon. But if you do separately, one line, okay, then you don't need to put semicolon. Okay, you don't need to put semicolon. It is assumed that there will already be semicolon at the end of the line. Okay, so this part, schema inclusion transition here is actually the one that I told you. If let's say you want to add your friends into your system, your friends module into your system, or later, if let's say you have two module, then after that you want to combine into smaller, then you can do schema inclusion. This one I will tell you also about how to do this later. Okay, so example of your declaration is what we have done previously lah. Something like this. Okay, something like this. Okay, schema predicate. Okay, the diagram just now, the predicate will be the below one. Okay, so what you put inside there will be your constraints, will be the condition. Okay, will be what you want to tell other people is happening inside your system. Okay, so those are actually the predicate part. So what you wrote inside the predicate part must always be true. What we mean by that means, if let's say I want to say that in order for me to add the customer into the system, the customer must not exist yet in my system. So the statement that I wrote, the customer does not exist in the system, must be true. If I wrote that customer exists, error occur, because if customer exists, I cannot add the customer into the system, so there will be an error there. So what you have to put there, whatever the statements that you put under predicate part must always be true, so that you can proceed. So every statement in the predicate part, whatever that you do, single statement, every single statement that you have in your predicate part, okay, at the end of the line there is a conjunction symbol. Okay, it's a conjunction symbol. Okay, what it means by that is, every single here must always be true. So one single statement true, and single statement is true, and so all n means all must be true. Okay, all must be true. But if let's say you make it individually, statement by statement, it's okay not to put conjunction. You can leave it without conjunction symbol. Except if you have one line, second line, you move second line to become first line, then you have to separate the line with conjunction. Okay, so that is actually how you do for your predicate part. Okay, so the first part, state schema or state space schema. This is the starting state. Okay, so what is actually related to your schema? This is the module. Okay, your module. So what actually you are trying to do in your module, you have to imagine what will be the one that you are going to communicate, or how to communicate with your database later. So what will be the variable that you are going to use to communicate with your database later. So this variable will be used all throughout your system, because this is actually something like your starting state global for your operation. For your operation only, not for your friend's operation. No, global for your operation. Meaning that whatever that you wrote there will be global for your parts. So whatever that you declare, or whatever the constraint that you put there, will be for all your operation. Okay, so this is actually starting state schema. Okay, so this is the static aspect of your system. Okay, so just know first, later I will show you how to do the static schema. Okay, the second, after that, I put also the initial state. Initial state normally for you to actually initialize your variable. That's all. The main purpose of your initial state is to initialize your variable, to make sure that, for example, all the records will be empty, for example, just to initialize your variable. So that is what we call as initial state schema. Okay, initial schema or initial state schema. Okay, then after that, the third step, okay, of your schema will be your operation schema. Operation schema, as I showed you just now, can be either query schema or change schema. So query schema means that you query, you ask questions. So means you want to get the answer, but your answer will not update the database data. Let's say I want to display the customer information. Just display. I will not update the customer information. It just display the information only. So when it is display, the operation schema display only, then you have to tell that this operation schema will not have an update in the database. How to show that this operation does not have an update to database? You have to put what we call as Z notation symbol in that schema. So this is a symbol that you must show in your operation schema. Just now state schema, no symbol like this, no. Except operation schema, you will have this symbol. If the operation schema does not have an update, then you have to use Z notation symbol. Okay, but if your operation schema change something in your database, doesn't matter one data or two data, three data, doesn't matter. At least one data is updated, then there is a change to your database data. So you have to tell that this operation schema has an update. You have to use delta symbol. Okay, so these two symbols are important for you to remember, because when you go for operation schema, I will ask you, does this operation has an update or not? If have an update, what will be the symbol to be used? Okay, so you have to know what will be the step, what will be the exact, exact symbols for you to use in your operation later. Okay, whether it is change state schema or query schema. So these two symbols are important, whether delta symbol or Z notation symbol. Okay, delta will be for change schema, whereas for Z notation is for query state schema. So these two are important. Just remember the symbol first. Okay, and then after that, you have to know. I think all of you have heard this word, pre and post condition. Okay, so normally precondition is something that you are going to do for checking. Okay, checking. So for example, if let's say you have an input, even though you have one input requested by the requested from the user, at least one input, you have to check that input. Okay, you have to check that input. Okay, if let's say you have one input, you have to check that input. So when you want to check for that input, this is what we call as precondition. Okay, so normally the input, what is the symbol that you have to do? You use question mark variable, right? So when you have at least one question mark variable, normally you will have a precondition to check on that input. Okay, and then it's up to your query. Okay, so the post condition normally related to your query. So for example, your output will be post condition because you produce output. You produce output that is your post condition. Or you update your database, also post condition, because you update your database. Okay, so normally it's up to your system. If it is query, the output will be the post condition, and then if it is changes and so on, the prime variable will be the post condition for your operation. Okay, so that is pre and post condition. So your pre and post condition, you can use less than, greater than, whatever your logic, your what a member of, not a member of all those symbols you can use in your precondition. Okay, so this is example. Assume that I have a basic type called student, where all the students who are in the badminton club here. Actually in tutorial 3 I changed to tennis or something like that. It's similar, where I have axiomatic definition for the max player of 20, per time, where they can be in the badminton hall, 20 maximum inside that badminton hall lah. Okay, so when I want to start my state space schema, okay, when I want to start with my state schema, so I need to know what I want to store in my database. So I want to store those who are actually in my badminton club, students list in my badminton club, and then student list in the badminton hall. Because those who are at badminton hall, I may have 50 students in my badminton club, but does not mean that all 50 students will be at the badminton hall. Maybe maximum, because I have 20 only, so I may have maximum 20 only inside the hall. So I need to have 2 records to share to say that these are those my badminton club members. These are actually those who are playing badminton now, for example. So inside the hall. So two database, one for badminton, one for hall. Okay, so how to show that these 2 database is actually by looking at your variable here. When you do 2 variable here, means that you have 2 database table. Okay, 2 table, 2 different table. Okay, so it's something like, let me go back to this one. I open a new one. Oh, you want to take a minute break? Okay, so let me show you the table first. Okay, so these are actually, this is badminton table. This is Sabah Hall. Okay, so both are actually power set of students. Means that the type here that I will store inside here, these are students. Here also. Okay? So assuming this, we take a few minutes break. Later I will explain to you about this. Okay, so we take a few minutes break, then after that I proceed with the lecture. Take a few